As you can see from the title of this tutorial, this video is about organic nomenclature. Designed for by AP kids, but if anybody else is watching, organic nomenclature is entirely different than everything we've learned so far. We have a current system which we do metal and non-metal, and that leads to certain rules. Organic chem is an entirely different branch of chemistry, and therefore gets its own naming and own writing system. Three things that you'll see that are similar or new. First, when we look at organic nomenclature, we will still have a molecular formula. So for instance, if something's molecular formula is C2H5OH, we can also draw out its structural formula, which shows how everything is connected. Instead of saying I have two C's, it tells me I have a C to C bond. Instead of telling me, well, where are the H's, where are the OH's, they show me where each of the components of the formula are. A lot of times what they'll do, as opposed to writing all of this out, because it eats up a lot of space, is they will show you a condensed structural formula, where it still shows the connectivity, 3 H's off of this C, 2 H's off of this C, but then you have to pull the H's out and realize that a C is connected to a C is connected to an O. And remember, with organic chemistry, we are always talking about chains of carbon, so you know that more often than not, the carbons have to be connected to each other. And the only thing that can change is we could put something off of the carbon chain at the end or the beginning, or occasionally insert something into the chain in between a longer span of carbons. If we start simple, we'll look at what we call hydrocarbons. And a hydrocarbon is simply an organic compound that only includes two elements, carbon and hydrogen. This will break down into three categories. The first category are called alkanes, with an A-N-E ending. Alkanes are carbon chains that consist of only single bonds. To get their formula, all we need to know is how many carbons are in the chain, because every alkane follows the following formula: CnH2n plus 2. So as long as we know what N is, which is the number of carbons in the chain, we are able to predict the number of hydrogens that are there, because they all do the same thing. So for instance, say carbon were 2, we'd have C2H2n, which would be 4 plus 2. C2H6 is the formula for that alkane. The second category, are called alkenes. Up here in the green, alkenes contain at least one double bond in the carbon chain. It could have more than one, and that you will hear those called dienes or trienes if there's three. But at least one double bond will make the ending of the phrase ENE. It gets the formula CnH2n. It will change the formula from what we did for alkanes, because the double bond will eliminate hydrogen atoms. Third type that we'll talk about are called alkynes. And alkynes contain at least one triple bond. So the YNE ending indicates a triple bond somewhere in the chain. Its formula is always CnH2n minus 2. And you can use those to predict what the formula of something is, or if you saw a word like hexine, you'll learn what the prefix hex means and plug that in for N, and you can figure out its molecular, structural, or condensed structural formula. So anytime we're going to tackle nomenclature, there's always two things we have to do. The first thing we have to do is be able to write the name of something if I am looking at its formula. Whenever we're working with organic compounds, that's a three-step process. Step number one of writing the name is we have to locate and identify the longest carbon chain and then determine the prefix. So if we're looking at a structural formula where there's a lot going on, you have to see the longest string of carbons in that chain. They may not be in a straight line. It may include things that are up and above or down and below. If a C double bond is present or a C triple bond is present, they must be included in the chain. So if you can make a longer chain but it doesn't include the double bond or the triple bond, that is no good. You have to involve the double bond or the triple bond into what you are labeling as the longest chain. Once you figure out how many carbons are in that chain, you give it the correct prefix for that number. And the prefixes are different than the ones that we have learned in the past, which were for nonmetal nonmetals, our covalent structures. That was mono, di, tri, tetra, right, penta, hexa, and so on. Like, the prefixes for organic are a little bit different. Right? 1 carbon chain would be called meth as a prefix. 2 is eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. So the good news is a lot of them are the same, right? From the covalent structures to organic structures, right? Pent, hex, hept, oct, non, dec, all the same. The only ones you have to remember the difference is for the first 4. 1 is meth, 2 is eth, 3 is prop, and 4 is bute. Right, then we'll add to that prefix the ending ane, ene, or yne, depending on, is it all single bonds? Are there double bonds in there? Or do we see triple bonds in there? Right, so that's how we get what we call the base chain. Right, so we name the base chain first. Right, once we name the base chain, then we have to follow step 2. Look for substituent groups off of the main chain. Right, and substituent groups are things that aren't part of your longest carbon chain, right, but are still connected to that chain. Right, and there's a various assortment of them. Right? We will have CH3s that are off the main chain but are not in our chain. Right? And if we identify those, we call those methyl groups. CH2CH3, right, has 2 carbons, but as a substituent group, it's not eth, it's ethyl. CH2CH2CH3 are a chain of 3 that's off of a longer chain. Again, it's not prop. Whenever it's a substituent group, it's pro-bull. And then lastly, 4 carbons in a row off of a much longer chain, like a 9 or 10 chained carbon, would get the identification tag of butyl. Other things that you'll see off the chain, right, that we would need to indicate would be a halogen, like Br, Cl, or F. All of them are like you see them on the table, except they end in O. Right, so Br is bromo, Cl is chloro, F is fluoro, right? And we didn't put it up there, but if I saw a I, it would have been iodo, right? And so on and so forth. A couple points I want to make about when we label our chains. First thing, when we number our main chain, which you will have to do, right, you always try to give the substituent groups, one of these guys that's off of it, the lowest number possible. Right? So if I see a long chain and there's an F on the 2nd carbon, or there's an F on the 7th carbon, I'm going to order the chain so that F can be off of what I label as carbon 2. And you'll see us go through. Other things related to substituent groups, if there are multiple substituents, right? For instance, say there was a CH2CH3 group and a Cl group off of a carbon chain, which can happen, right? We list those alphabetically when we're naming them. Right? So we'll put our substituent groups ahead of our base chain name, right? But how do I know what order to do that in? I will always do it alphabetically based on what we see with the substituents. The other thing that you'll have to do with the substituents is tell me how many there are if there's more than one. Right? If there's more than one of the same type, we use our normal prefixes, right, to tell everybody how many there are. For instance, say I had 2 CH3 groups off of my main carbon chain, I would call it not methyl, but dimethyl. If there were 3, it would be trimethyl. Right? If there were 4, it would be tetramethyl. Right? If I had 4 of the bromines off, it would be tetrabromo. So you have to tell me not only what is the group, but how many of them are there. Right? Coupled with that, you will also have to tell me where they're located on the chain. What number carbon are they off of? Right? So I may see things like 2,4-dimethyl, which tells me I have a CH3 off of carbon 2, right, and a CH3 off of carbon 4. And you'll see that as we go through. Right? But the second thing you have to do after you write the base chain is find your substituent groups. Right? After that, we get into some of the stuff I was talking about with labeling the chain. Right? And in terms of numbering my carbon chain, I am always going to number it according to these rules. I will give the double or the triple bond the lowest number possible. Right? So if I have a F off of the 7th carbon and a double bond off of the 4th, that's okay. But if I labeled something that has 1 fluoro and then 7 ethyl, that's no good. Then we go to the other groups. So you always take care of the double and triple bonds first, then we do our other substituent groups. So let's take a look at some examples and generate some names for what we see. All right, first thing, if you get a condensed structural formula, the first thing you want to do is write it out as a complete structural formula early on until we get the hang of this. All right, so CH3 means I have a carbon. And off of it, 3 hydrogens. Right? Then we're connected to a second carbon. It has 2 hydrogens. And you'll notice all of these carbons are going to be linked. So there's 1, 2, 3, 4, 5, 6 carbons. So 1, 2, 3, 4, 5, 6 carbons. And if I put H's on all of those lines that I drew, you'll see where these come from. H3, H2, 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 and then H3. So if I want to name this thing, the first thing I'm going to do is find the longest carbon chain that I see. Right? So I see a string of 1, 2, 3, 4, 5, 6 carbons. Right? That is the longest chain. There were no carbons off of this, right? Though you will see things like that at times. This could have happened. Right? And say there were H's off all of those. Right? You can't say, oh, 1, 2, 3, 4, 5, 6 is the longest carbon chain, right? Because take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be your longest chain. Doesn't matter if they make a bend, they're just having to be connected to be considered a chain. Right, but we'll jump into that there in a minute. Okay, so my longest carbon chain is 6. So I'll put the prefix for 6, which is hex, right, in front of ane, ene, or ine. So if we have all single bonds, it'll be an ane ending. If there's a double bond, it'll be an ene ending, and I'll have to say where it is. Or if there's a triple, an ene ending, and I'll have to say where it is. Well, we have all single bonds, so we're going to call it hexane. Then I look for substituent groups off of the main chain. Well, if I look at my main chain, all I see off of my main chain are hydrogens. That's not a substituent group, right? So that means I don't have to put anything in front of hexane. Right? So the name of this compound would simply be hexane. Graduating into a couple others. Let's take a look at something like this. CH3 CH Br CH2 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 CH3. First thing I want to do is draw myself a structural formula for this. Right? So the carbon's going to be connected to the carbon, it's going to be connected to the carbon, to the carbon, to the carbon, to the carbon. Right? The only thing that will ever get inserted into the chain could possibly be an oxygen. Like BRs, Fs, anything else, if it's written in the line, means it's off of one of the carbons. So I see 1, 2, 3, 4, 5, 6 carbons in a row, so I'm going to draw it. 1, 2, 3, 4, 5, 6 carbons in a row. Off the first carbon, I see 3 hydrogens. Off the second carbon, I see 1 hydrogen and 1 bromine. Off the third carbon, 2 hydrogens. Off the next carbon, 2 hydrogens, 2 hydrogens, and 3 hydrogens. So the first thing I do is I identify the longest carbon chain. Right? If we take a look, I see 1, 2, 3, 4, 5, 6. So I'll give it the prefix for 6, which is hex again. It is all singly bonded, so it's going to be ane. And then I start looking for substituent groups. Well, this time you can see I've got a Br off of one of my carbons. So we take a look and see what that's going to be called. And a Br group is called bromo. Are there any others in the chain? There is not, right? So I know it's going to be bromohexane. Right? There's only one, so I don't need a prefix in front of bromo. Right? But I do need to indicate where the compound has the bromo group at. So now I have to number or label the chain to get the number. Right? So there's 2 ways I could number this. I could either start here and say carbon 1, 2, 3, 4, 5, 6. Or I could start from here and say carbon 1, 2, 3, 4, 5, 6. So if I use the first one I drew, making this carbon 1, this would be 2-bromohexane. If I use this as the number 1, it would be 1, 2, 3, 4, 5-bromohexane. So how do I know which one is correct? And that's what I was talking about here. We always number the main chain to give the substituent the lowest number possible. Right? So numbering it from one side tells me 2-bromo. Numbering it from the other side tells me 5-bromo. So I am going to give it the lowest number that it can have. So it will be 2-bromohexane. And so you tell me where the substituent group is and how many, labeling it so that it gets the lowest number possible. Let's try 2 others. Example 3. And example 3 is CH2, C, and then parentheses, CH3, CH2, CH, Cl, CH2, CH3. Right, so first thing we're going to do, identify the longest chain, which means we want to draw this guy out. So why is it I see a CH3 in parentheses? That is a condensed structural formula's way of telling you that is not part of your main chain. It is off of your main chain, so they throw it in parentheses and say don't include that in the chain. Right, so if I start trying to count for how many carbons I should get, I see 1, 2, ignore, 3, 4, we don't put CLs in, 5, 6. So once again, I am at 6 carbons. So I'm going to string 6 carbons together. 1, and the first one has a double bond. Right, then it's all singles. So 3, 4, 5, 6. Now you'll put the elements off. 2 H's, so H, H. Here, no H's, but it says I have a CH3 off of it. So I'll put that there. And notice, 2, 3, 4 bonds for carbon. That's why there's no H's, right? Because we can only make 4 bonds with carbon. 2 H's off of this carbon. This has 1 H and 1 Cl. This one, H, H, and this one, 3 H's. So, first thing I need to do is find my longest carbon chain. Right? Remember, if there's a double or triple bond, it has to be in the chain. So you could have said, is this 1, 2, 3, 4, 5, 6 chain, or 1, 2, 3, 4, 5, 6 chain, you have to use the one with the double bond in the chain. Right, so, next thing we'll do is write the prefix for 6, which is hex. Then we'll put the correct ending on it. Is it singles, doubles, or triples? It is double, so we're going to call it hex-ene. You're going to want to label, right, where that double bond is, right? So it could either be 1, 2, 3, 4, 5 hexene, or it could be 1, 2, 3, 4, 5, all right, 6. It could be 1 hexene. We always give the double bond the lowest number. So we're going to say 1-hexene. And that does our numbering for us. So 1 there, 2, 3, 4, 5, 6. So when I move on to my substituent groups, right, I've already placed the numbers on there for them. I'm going to have a CH3 group off of here, which is called a methyl group. And then I have a Cl group off of here, which is called a chloro group. So now I'm going to have 2 methyl, 4 chloro. So how do I decide what order to write those in? It is alphabetical, right? So chloro is C, methyl is M. So I am going to write 4 chloro, comma, 2 methyl, 1 hexene. And so 4 chloro, 2 methyl, 1 hexene. One more like that. This time, let's take a look at CH3, C, parentheses, CH3, 2, CH, double bond, C, parentheses, CH3, CH2, CH3. Again, the parentheses in there indicate that is not part of our string of carbons. So when I start counting up how many carbons to write my structural formula, 1, 2, don't worry about these, 3, 4, don't worry about this, 5, again, 6. And I keep choosing 6 to make the point of how we can manipulate these. Right? So we draw 6 carbons. 1, 2, 3, 4, 5, 6. And now you can start filling in. Off the first carbon, 3 H's. Second carbon, no H's. I have 2 CH3s. Off of the third one, I have an H. There's a double bond. And then off this carbon, I have no H's. I have a CH3 group. And then off of this, 2 H's. And off of this, 3 H's. So the next thing I do is I find my longest carbon chain. Right? So if we look at all our possibilities, I see 1, 2, 3, 4, 5, 6. I see 1, 2, 3, 4, 5, 6. I see 1, 2, 3, 4, 5, 6. I see 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. Right? So any way I break it down, the longest string of carbons is 6. And remember, you have to keep the double bond in the chain. Right? So again, that means I'm going to get hex as my prefix. I see a double bond, which means it's going to be ene. So hex-ene. Now I need to number this thing to get that double bond to have the lowest carbon number possible. Right? So if I mark the chain this way, it's 1, 2, 3, 3 hexene. If I mark it this way, 1, 2, 3, 3 hexene. This way, 1, 2, 3, 3 hexene. 1, 2, but that wouldn't be a chain of 6, so I can't do it that way. Right? So it's going to be 3 hexene. Then I have to put my substituent groups in front of it. So I start looking for substituent groups. Well, here's a CH3, here's a CH3, here's a CH3. Those are all the same group. They are called methyl. And the catch is, I don't just have one methyl, I have three. So that means I'm going to write trimethyl for my name in front. And then I have to tell everybody where are those methyls at. So according to this, right, I have on the second carbon 2 different methyls. So we will say 2, 2, and then the next methyl is off the fourth, 4. So the name for this would be 2,2,4-trimethyl-3-hexene. Right? So it's all about just labeling your chain, identifying the groups, getting numbers on each. So the names look really complex, but when you understand where they come from, they start to get simple. Hey, methyl means a CH3. Trimethyl means I have 3 of them. 2, 2, and 4, oh, that's telling me where those CH3s belong on my chain. Well, how long is my chain? Oh, it's hexed, so that means there's 6. Oh, E means I have a double bond. Right? Where's that double bond? Oh, it's on the third carbon. And it seems a little overwhelming at first, but the more you practice at it and the more you do it, it will get much, much more manageable. Right, so that's the ticket if you are going to try to write the formula, right, of what's going, the name of what's going on. And in my opinion, that is by far the tougher of the 2 tasks. Right? The other side of the coin, other than writing the name, is writing the formula. Right? And writing the formula steps are pretty straightforward. Right? I say you follow directions. You basically do what the formula is telling you, what the name is telling you to do. Right? But you have to be careful for the endings, because the endings could indicate that you're changing the carbon chain. Right? Now, a couple of these we talked a lot about. If I see an ANE ending, that means I just have single bonds. ENE means there's a double bond. YNE means there's a triple bond. If you see an ending on a name that is OL, right, an all, that is an alcohol. It means we have to put an OH group off the end of the carbon chain. If you see an one, right, like butadiene, for instance, right, you are working with a ketone, which means somewhere in the carbon chain there's a double bonded O off of a carbon. And they call that a ketone. It's called a special functional group. If something ends in oic acid, it's called a carboxylic acid. At the end of your carbon chain, you will always have this picture, double bonded O, OH. And they call them carboxylic acids. And then last but not least, if you see something end in not ane, but al, A-L, all right, that is an indicator of what we call an aldehyde. At the end of the chain, off the last carbon, you have to have a double bonded O with an H. So the easiest way to work with these is by looking at the formulas. So we'll do a series of formulas right up here, and I'll go ahead and erase this so we have some space to work. Like I said, writing them, much easier. You just follow directions. So the first thing I always do is zero in on the ending. Right? So octane means ANE, all single bonds. Oct means there's 8 of them. Right? So 1, 2, 3, 4, 5, 6, 7, 8. 8. That's octane. Now, tetramethyl. Methyl means CH3. Tetra means 4 of them. So I'm going to put 4 CH3s off of this chain, and this tells me where they go. 2, 2 means off of carbon 2, I put 2 CH3s. 4 means 2, 3, 4, another CH3. And then 5 means another CH3. And you could put them on the top or the bottom. I just separate them for space sake. And then last but not least, right, what you would want to do is fill in the rest of the spaces with hydrogen. So 4 bonds needed, that means this gets 3 more H's. This gets 2 H's. This gets 1 H. This gets 1 H. 2 H's, 2 H's, 3 H's. Right, so that's the drawn out formula. If I condense that to a structural formula, right, I'm going to write what I see. CH3, parentheses. In fact, let's not even do that. All right? You guys will be just fine to leave it as the structural formula. Get yourself to that picture, and you will be good to go. Right, second example would be if I saw butanoic acid. Right, so first thing I have to do is look at the ending to figure out what's going on. I see an oic acid, which means I'm going to have C double bonded O, OH at the end. Now I have to figure out, well, how long is my carbon chain? Well, the but prefix, if you remember, is 4. So I'm going to do 4 carbons. 1, 2, 3, 4. Right? But the very last carbon is going to have the carboxylic acid ending, which means I have double bonded O, OH off of the end. And then from there out, fill hydrogens in the rest of the way. And when we do these, right, if you don't want to put the hydrogens in, that's okay. Right, that's a lot of H writing, and it's implied that if you just draw that picture, that there are H's on the end. Third one, 2-butanone. Right, I look at the ending. Right, it's an O-N-E ending. That means we have a ketone, which means there's a double bonded O somewhere in the string of carbons. Right, so if there's a double bonded O somewhere in the string of carbons, we have to figure out how many carbons. Again, but means 4. So 1, 2, 3, 4. Right? O-N-E means I have to put a double bonded O off of one of them. Well, which one? That's why the 2 is there. So that means I'm going to put a double bonded O right there. And then the rest of the spaces will get H's. Just like that. Last but not least, let's look at methyl propanoates. Okay, if you can see, this one here ends in O-A-T-E. Oh, and I just realized that I hadn't written it up here. All right, so add this one to the bottom. O-A-T-E, right, is called an ester, which means you get one of these in the chain somewhere. A double bonded O, like a ketone, but instead of being C's on both sides, you get an O in the chain. Okay, so propanoate means that I am going to have, right, a double bonded O with an O off of the carbon in the chain. How long is the chain? Well, prop means that there are 3 of them. Okay, so let's clear some space. So we'll go 1, 2, 3. And then propanoate means I'm going to have a double bonded O with an O off of that in the chain. So what you're going to have to do is go in and insert the O into the chain. Right? You start with the double bonded O, O. Right? And then methyl propanoate, right, means that you are going to have a CH3 group at the end off of your 3 carbons. Right? So methyl propanoate would look like this, with H's off of those. Nothing off that C because there are already 4 bonds. Right, so that's a little bit with the structure drawing and the name drawing. Right, the last thing you'll see, and what we will use the most of, is reaction prediction. Right? So I think sometimes this is the most complicated, just learning the naming system, but then using it is pretty straightforward. Right, so we're going to look at some simple organic reactions. Right, and the first one that we'll look at is called an addition reaction. Right? In addition reactions, what is going on? Right? Well, when we look at our reactants, we are going to see either a halogen or hydrogen reacting with an alkene or alkyne, something that ends with ene or yne. Right? What is the main characteristic of this type of reaction? The double or triple bond goes away, right, and it gets replaced, right, by the halogen or hydrogen, depending on what you see. Right, so if you see this, it would look like chlorine plus propene. Now, this is one of those ones it's easier to get the products first before you predict what the word answer is going to be. Right, so chlorine is a Oberfinkel, so you would say Cl2 plus propene. Prop means 3 carbons, so 1, 2, 3. Ene means there's a double bond, and it doesn't matter where we put it, it will be here, which means the rest of these guys are going to be H's. One off there. Right, so what's going to happen is this double bond is going to go away. All right? And when the double bond goes away, that opens up a space on this carbon and this carbon. And when that happens, chlorines fill those spaces. They add to the chain. Right? So we'll still have 1, 2, 3 carbons, except now this will have 2 H's and a Cl. This will still have the 3 H's. This one will have an H and a Cl. The great news is if you don't want to draw this, you do not have to. Right? You can write formulas for this. Right? Chlorine is Cl2 plus prop is N equals 3. And if we go way back to the beginning with an alkene, if this is 3, we know the formula. It would be C3H6. And then because it's an addition, all you do is add them together. C3, H6, Cl2. You simply add the Cl to the C3H6. Sometimes you'll see that happening with a triple bond. Right? What does it look like if it happens with a triple bond? Well, with the triple bond, they'll look like this. It will say excess chlorine gas is added to ethine. Right? So you would say, okay, chlorine gas, there's my reactant, Cl2. Ethine, eth means 2. So to get my formula for an alkyne, C2H2N minus 2, right? So C2H4 minus 2 would be 2. So it would be C2H2. The idea here is if you have excess chlorine gas, you add as many chlorines as there are double bonds or triple bonds to break. So the picture for this would be like this. Cl2 adding to this. Well, now, if I take away 2 of these, I open up 2 spots on each of these guys. Right? So I'll be able to add 4 chlorines to a triple bond. Right? So this would simply be C2H2Cl4. Right? So that's your first type of organic reaction, called an addition. Right? Second type is called a substitution. With the substitution, you've got an alkane plus some halogen. And the key to this is a halogen replaces a hydrogen. It's the idea here is we would see something like this. Bromine plus pentane. You would figure out what this looks like. Bromine, Br2, that's my halogen. Here's my alkane, ANE. That's what makes it not this, but this. Right, so pent is C5. Anes are 2N plus 2, so H12. All that's going to happen is a Br is going to replace an H, and an H is going to replace a Br. Right, so you end up getting C5, H11, Br plus HBr. Right? One of the BRs breaks up and swaps with a hydrogen. Right? The third type we've done before, those are combustions, right? And you know how those work. It's always a carbon dioxide plus water product. Right? But the last one, right, are called an esterification. Okay, and an esterification is a carboxylic acid plus an alcohol. Right? And those always produce an ester plus a water. Right? So if you see something that says oic acid plus something that says all, like ethanoic acid plus 1-octanol. Okay. What you want to do is get yourself formulas. Ethanoic acid means 2 C's, and an oic acid means double bonded O, OH. Octanol means 8 carbons.
Nathan McCandless, Emily Sanchez-Perotti, and Katie Lacey, please come to the office.
An H.
Michael Black, please come to the office.
Right, is with the carboxylic acid, this H combines with the OH to get us our water. And then the rest of it just smashed together. We'll get the C2 or CH3, C double bonded O, O, and then you slam this portion in front of it. So dash C8, H17, and the OH is gone. And structural formulas would be perfectly fine for that, right? But sometimes this gets written CH3, COO, C8, H17. Right, so I hope this video helped. Take a look. That should be enough to get you through the packet. If you have any questions, as always, please come in and ask for help.